Take a look at the screen. Right now, it's just a blank screen, but in just a moment, I'm going to switch slides, and for just a few instances, there's going to be a bunch of letters appearing. And your job is to see how many of these letters you can remember. All right, are you ready? Here we go. How many did you get? So pause it or just think to yourself, how many of those 12 letters can you remember? And now let's go back and see how you did. All right. So if you're like most people, you probably did not remember all 12. In fact, in the average experimental condition, people remember about a third of these. So maybe you got about 4. If you did, congratulations. But what I'm trying to get at is the research of a psychologist named George Sperling. George Sperling was doing his research in the 1960s, and what he was trying to demonstrate was when it comes to encoding, which is the first stage of our 3-stage processing model, we encode billions of bits of information. So let's think about vision. When it comes to our visual input, we do, according to Sperling, we do take a perfect picture, a perfect photograph of everything we see. And that's called iconic memory. Iconic memory is the idea that we actually, for a brief moment of time, remember every single piece of information that we see. But every single piece of information includes billions of bits of information. And as we're going to talk about, the next stage of memory, working memory or short-term memory, can only actively process an average of 7 pieces of information. So of course I can't remember billions of bits of information for any significant amount of time. And so at a conscious level, it really feels like I don't remember much at all. But Sperling wanted to prove that we actually all have photographic memory. And so to do this, he sets up the experiment with a different group of people and changes one thing. He tells the participants that he's going to show these letters for just 1/12 of a second. That is extremely fast. But right when the letters go away, you're going to hear a tone, a sound. It's either going to be a high-pitched sound, a medium-pitched sound, or a low-pitched sound. And the high, medium, and low refers to the top row, the middle row, and the bottom row. What's really fascinating here is that the subjects did not know what row to pay attention to because they weren't going to hear the tone until after the letters had already gone away. But what he found was, if he flashed the letters for just 1/12 of a second and then played that tone, and then asked people to remember or to retrieve the letters on that associated row, the accuracy went up to almost 100%. In other words, at least for a brief moment of time, just a few seconds, people did take a perfect photograph of this information, all of it. But we can't remember all 12 letters because it goes away so quick. But we can at least remember enough to refer, based on what tone we heard. So this is known as iconic memory. And this is a great example to demonstrate that when it comes to encoding and the sensory register, we register or encode so much more than we actually think. And that's pretty much because our brains can't handle as much information as actually comes in at us. So this is where our central executive enters. We have to decide, from an evolutionary perspective, what is worth paying attention to and what is worth ignoring. We have to make those decisions, and I think that's one of the things we learn as we grow older is what is worth my limited attention span, because I can't pay attention to everything.